In this problem, we want to solve for x given 4 raised to power x times 64 raised to power x is equal to 100. There is more than one approach to solve this problem, but I'm going to work on this 64 first of all. 64 can be expressed as 4 raised to power 3. Therefore, the new equation will become 4 raised to power x times 4 raised to power 3 raised to power x is equal to 100. Using simple laws of indices, starting with one such as this, a raised to power m raised to power n, in indices this can be expressed as a raised to power mn. So that will help us to simplify this. We have 4 raised to power x times 4 raised to power 3x is equal to 100. Now, on a closer look, you have 4 as a base here and here. Therefore, we can use another law of indices to bring them together since they have common base. And the law we are going to apply is a raised to power m times a raised to power n, same base, different power. You express them as a raised to power m plus n. We are now going to have 4 raised to power x plus 3x is equal to 100. This is 4 raised to power 4x is equal to 100. Now let us take the logarithm of both sides. This is log 4 raised to power 4x is equal to log 100. We're going to apply a law of logarithm. Log p raised to power m is the same thing as m log p. So we would have 4x times log 4 is equal to log 100. We can divide by log 4 on both sides. This removes this. So 4x is equal to log 100 over log 4. Now 100 can be broken down into 4 times 25. And 4 is 2 squared. 25 is 5 squared. So I'm going to first separate by writing log 4 times 25 divided by log 4, and then apply another law of logarithm which says given log, you have product of two numbers, you can separate them into sum of individual logarithms. So this will give us 4x is equal to log 4 plus log 25, then divided by log 4. And now we can use everything we got here. So, but before then, let me separate this division into log 4. divided by log 4 plus log 25 divided by log 4. I had to quickly do this part because this cancels this, gives us 1. And then we can now turn this to 5 squared and turn this to 2 squared. So we have 4x is equal to 1 plus log 5 squared divided by log 2 squared. And recall the law we used earlier. Given log p raised to power m, you can express this as m log p. So 4x is equal to 1 plus 2 log 5 divided by 2 log 2. And with that, this 2 cancels this 2. And we can say 4x is equal to 1 plus log 5 divided by log 2. Now we can divide through by 4 to get our x. This will be times 1 over 4. So this takes care of this. And our x is equal to 1 over 4 plus 1 over 4 times log 5 divided by log 2. We are closer to the answer, but this expression, using this law of logarithm, log a divided by log b is log a base b, then the expression can become log 5 base 2, giving us the final answer to this problem. And to verify that our solution is correct, we're going to go ahead and substitute everything we just got for x into our actual question, which was 4 raised to power x times 64 raised to power x is equal to 100. So this is 4 raised to power 1 over 4 plus 1 over 4 log 5 base 2 times 64 raised to power 1 over 4 plus 1 over 4 log 5 base 2 is equal to 100. I'm going to apply a law of indices at this point, and the law I'm going to apply says given a raised to power m plus n, you can express this as a raised to power m times a raised to power n. So we expand each of these to give us 4 raised to power 1 over 4 times 4 raised to power 1 over 4 log 5 base 2 times 64 raised to power 1 over 4 times 64 raised to power 1 over 4 log 5 base 2 is equal to 100. Let us work on this, and probably this. We have 4 raised to power 1 over 4 times 4 raised to power 1 over 4 log 5 base 2, and 64 is 4 raised to power 3, then raised to power 1 over 4. 64 is 4 raised to power 3 raised to power 1 over 4 log 5 base 2. So we would use this law of indices to open this bracket. A raised to power m raised to power n is simply a raised to power m times n, giving us 4 raised to power 1 over 4 times 4 raised to power 1 over 4 log 5 is 2. So this will be 4 raised to power 3 over 4 times 4 raised to power 3 over 4 log 5 base 2 is equal to 100. Now let's bring them together. This and this can come together to give us 4 raised to power 1 over 4 plus 3 over 4. Then I'll bring the rest together as well. So this is 1 over 4 log 5 base 2 plus 3 over 4 log 5 base 2 equals to 100. So we have 4 raised to power, this will be 4 over 4. Then 4 raised to power, the same thing, 4 over 4 log 5 base 2 is equal to 100. Of course, 4 divided by 4 here is 1. The same thing here is 1. What we are left with is 4 raised to power 1 times 4 raised to power log 5 base 2 is equal to 100. I'm going to change this to 2 raised to power 2 so that I have 4 times 2 raised to power 2 log 5 base 2 is equal to 100. And then I can return this as a power here to give me 4 times 2 raised to power log 5 squared base 2 is equal to 100. 4 times 2 raised to power log 25 base 2 is equal to 100. In logarithm, given p raised to power log m base p, as long as this p and this p are the same, the result is always m. Therefore, we have 2 here, 2 here, the result will be 25. So we would have 4 times 25 is equal to 100. And of course, 4 times 25 is 100, making the left-hand side exactly the same as the right-hand side, which confirms that our solution for this problem is perfectly correct. Thanks for watching. Remember to like and share if you have enjoyed this video. Subscribe to my channel and I'll see you in my next video. Bye.